Question number 8. We want to know what what the object in this velocity versus time graph is doing. So let's note right here, we're going very fast and we're moving forward. Remember, this is a velocity versus time graph, not a position versus time. Here, we're going backwards, but also fast since our value is so negative. And then here, for a really quick second, we're stopped. Let's try to put all this together. So it seems that we start off fast going forward, we slow to a stop, and then we speed up going backwards. So let's see if any of these apply. Unless you're moving forwards, it slows down, stops, and speeds up going backwards. Choice A. All right, for number 9. An object is dropped from rest from a height of 11.25 meters. We want to know what its speed is when it hits the ground. They don't give us time here. Because they don't give us time, I'm going to use the kinematics formula that has no time. So I'll use v squared equals v naught squared plus 2 times a times x minus x naught. We assume that the initial position is 0 and that we know the initial velocity is 0 since it's dropped from rest. So we're going to get v squared equals 2. G is the acceleration times x minus x naught, which is 11.25 minus 0. And so when we actually solve for v, the number that we're going to get is equal to 15 meters per second. Now this object is dropped from a height of 11.25, and we want to know how much time it takes to hit the ground. I'm actually going to use the answer to 9 to help me do number 10. So I'm going to actually use v equals at plus v naught. So I have v is 15 and a is 10. T is the time that I'm solving for, and I start at a speed of 0. So 1.5 seconds is what I end up getting for the time, which is choice C. All right, now positive means forward and negative means backwards. An object is moving forward with negative acceleration. We want to know which statement is true. So let's be clear. If we're moving forwards with negative acceleration, that means we're moving forwards this way. But since our acceleration is backwards, it must mean that we're slowing down since the acceleration is fighting the fact that we're trying to move forwards. All right, number 12. It seems like we're doing the same question over and over with the kinematics. So we want to know how high a rocket goes if it's launched with a speed of 40 meters per second. We don't have time. We know that the position it starts at is 0. We don't know what the final position is. We don't know what time is. We know that acceleration is 10. We know that v initial is 40, and we know that v final is 0. And you know what? Because it's moving upwards, we're going to call upwards positive. I'm going to make this acceleration negative 10 since it's downwards. So what this actually gives us is v squared is v naught squared plus 2a x minus x naught is our formula since they don't give us time. So I'll put in 0 squared equals 40 squared plus 2 times 10 times x minus 0. And when I actually simplify this out, I'm going to end up getting 80 meters for my height. All right, number 13. So we have 2 buggies, and we want to know how the distance compares for how they traveled. So let's actually get the area here. The area is going to be 1/2 base times height, because that's how you get the displacement or the amount traveled, the net amount traveled, when you have a velocity versus time graph. And here the area is going to be length times width. So here on the left graph we have 1/2 times the height, which is 20, times the base, which is 10. And so I'm getting 100 centimeters worth of displacement. And then here the length times width is going to be 10 times 10. That's also 100 centimeters. So they actually travel the same amount, and that's how we're getting choice C. For number 14, we actually just calculated. They each travel 100 centimeters forward. So that's it for 13 and 14, and in the next video we will finish up the multiple choice section.